Now let us see a derivation for finding out an acute angle between any two given lines. That means suppose we are given the equations of the lines, then how do we find out the angle between them, right? Now to find this, let us consider a diagram first. That is, let us consider the two lines are as shown here, and if you remember, we are trying to find out the acute angle between them. So let us assume that this is the acute angle theta as shown between the two lines. Now let's consider the theta 1 and theta 2 as the inclinations of two lines, right? So this is of course case 1. There is another possibility also, that is, you may have the lines oriented in such a way that the acute angle between them lies in this manner. That is, here it was as shown on top of the triangle formed, and here it is outside the triangle, right? The inclinations are still the same of the two lines, that is theta 1 and theta 2. Now let us see these two cases and find out a expression for angle between them. Now in first case, if you observe, theta plus theta 2 is equal to theta 1, because theta 1 is the exterior angle of the triangle here, and we know that exterior angle is equal to sum of the remote interior angles. Okay, so therefore here we get theta is equal to theta 1 minus theta 2. So therefore if you take tan of theta, we get that to be equal to tan of theta 1 minus theta 2, right? So this is the first expression that we get. Now let us see what happens in the second case. Now in the second case, since theta is the outer angle, the inner angle, that is the one of the remote interior angles, is pi minus theta. So clearly by adding that we get pi minus theta plus theta 2 is equal to theta 1, correct? So therefore pi minus theta is equal to theta 1 minus theta 2, right? So taking tan of both sides, that is tan of pi minus theta is equal to tan of theta 1 minus theta 2. Now we know that tan of pi minus any angle is equal to minus tan of the same angle. So therefore minus tan theta is equal to tan of theta 1 minus theta 2. So therefore we can say that tan of theta is equal to minus tan of theta 1 minus theta 2. So this is what we arrive at in the second case. So now if you compare the expressions for tan theta that we have got in both the cases, we observe that the right hand side is the same in value but opposite in the sign. That is, in the first case we have plus tan theta 1 minus theta 2. In the second case we have minus tan theta 1 minus theta 2. So therefore we can write it together as, if we want the acute angle theta, then tan of theta can be written as mod of tan of theta 1 minus theta 2, which is nothing but the absolute value, which always will be positive. And since we want the acute angle, its tan has to be a positive number, right? And now expanding the expression for tan of theta 1 minus theta 2, we know the formula, compound angle formula, that gives us tan theta 1 minus tan theta 2 upon 1 plus tan theta 1 into tan theta 2. And we can replace tan theta 1 by m1, which represents the slope of first line, and tan theta 2 by m2, which represents the slope of the second line. So therefore finally we get tan theta is equal to mod of m1 minus m2 divided by 1 plus m1 into m2. So that's the formula for finding out the acute angle between any two lines whose slopes are known to us. So once we know the inclinations, we know the slopes also, and vice versa, right? Now let's go ahead and see some of the corollaries or the other deductions based on this formula. So now if the two lines are having these equations, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, these are the general forms of the equations, then the angle between them is given by this particular formula, that is tan theta is mod of a1 b2 minus a2 b1 upon a1 a2 plus b1 b2. Now we may wonder from where this comes. Now that simply comes from substituting the values for the two slopes. Now we have seen that from the general equation the slope of first line can be written as minus a1 upon b1 and slope of second line can be written as minus a2 upon b2, correct? So therefore putting these two values in the formula that we have just derived, which is tan theta 1 is equal to mod of m1 minus m2 upon 1 plus m1 m2. So when we substitute the values of m1 and m2 from above and simplify, we get the result as shown here, right? So that is just another expression or another way of writing the formula for angle between two lines. Now based on this we can also find out a condition, or we can check whether the lines are parallel or perpendicular, that is the nature of the lines, right? So once again we have the two general equations of the lines. Now if you have the ratios of the corresponding coefficients exactly same, then it means that the two equations are not really different but they are one and the same. So that means they indicate the identical lines or coincident lines, like two lines are one and the same. Now on the contrary to it, if the ratio of x coordinates is same as ratio of y coordinates but that common ratio is not equal to the ratio of the constant terms, then it means that the two lines are distinct and parallel, right? Now why parallel? Because a1 is to b1 and a2 is to b2. If it is same, then it means that the slopes of the two lines are same, indicating they are parallel. But since the constant terms are different, that means the placement of lines is different, that means they are distinct lines. And lastly, if a1 a2 plus b1 b2 is equal to 0, then that indicates the perpendicular lines. Now this also can be proved very easily. Let's see how. We have seen earlier that for perpendicular lines the product of their slopes is always -1. So if we consider the first line, we can write its slope as minus a1 upon b1, right, from the general equation. And for the second line the slope is minus a2 upon b2, and this has to be equal to -1 if the lines are supposed to be perpendicular. So therefore multiplying, we have a1 a2 upon b1 b2 is equal to -1. That is cross multiplying, we get a1 a2 is equal to minus b1 b2, and hence bringing the minus b1 b2 term on the left side, we get the condition that a1 a2 plus b1 b2 must be 0 for lines to be perpendicular, right? Let's go ahead and solve a simple example based on the formula for angle between two lines. So here we have to find the acute angle between the lines whose equations are given, right? So let us start off. First of all, if you calculate the slope of first line, that is minus of 1 upon minus root 3, so that gives us 1 upon root 3, and slope of the second line m2 is minus of 1 upon root 3. That's it. Now let's write the formula, that is tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. Therefore putting the values, we have m1 equal to 1 upon root 3 minus m2 is minus 1 upon root 3 divided by 1 plus m1 is 1 by root 3 and m2 is minus 1 upon root 3. So in the numerator we get the addition, that is 2 upon root 3, and in the denominator we get 1 minus 1 upon 3, right? So that turns out to be 2 upon root 3 divided by 2 upon 3, right? So 2 and 2 will get cancelled, the 3 will go up and it will make 3 upon root 3, which is root 3, and that is nothing but equal to root 3. So if you see, tan theta has the value equal to root 3. So what does it mean? The angle theta has to be equal to 60 degrees, that is pi by 3 radians. So that's the acute angle between the two given lines.